Assalamu alaikum, how are you everybody? Today I will explain part 2, section 3, chapter 9, physics. Let's start our discussion with a review for the previous part 1, change in temperature. Brass is an alloy made from copper and zinc. A 0.59 kg brass sample at 98 degrees Celsius is dropped into 2.80 kg of water at 5 degrees Celsius. If the equilibrium temperature is 6.8 degrees Celsius, what is the specific heat capacity of brass? Here we have the objects. The first object is brass, and the second object is water. And given that the mass of brass equals 0.59 kilograms and its temperature T brass equals 98.0 degrees Celsius and mass of water equal 2.80 and the temperature of water equals 5 degrees Celsius. If the equilibrium temperature equals 6.8, this is the final temperature of the mixture. After mixing them, the temperature will be 6.8 degrees Celsius. What's the specific heat capacity of brass? Here, unknown is the specific heat of brass. Here it's unknown. And the specific heat capacity of water, seawater, equals approximately 4,200 joule per kilogram Kelvin. So the unknown here is the specific heat capacity of brass. How can we solve? Here, brass is hot, so it loses heat. And water is cold, so it gains heat. The amount of heat gained by water equals the amount of heat lost by brass, but here negative sign because here is gained and here is lost. And the amount of heat gained equals mc delta T. M water, seawater, specific heat, multiplied by change in temperature. Change in temperature equals Tf minus T water. Here Tf, this is the Tf final temperature, equals minus Q in brass, C brass, change in temperature, also Tf minus T brass. Let's substitute. M water 2.80, specific heat of water 4,200. Tf 6.8 minus 5.0 equals minus mass of brass 0.59, specific heat unknown, Tf 6.8 minus 98. This term can be calculated to be 21168 equals minus 50.16 times C brass. Dividing by, so it will be positive. Here negative times negative will be positive. Divided by 50.16 divided by 50.16. This term will be cancelled out. So C brass equals 420 approximately joule per kilogram Kelvin. Clear, guys? Okay. Let's start our lesson today. Phase change. What's phase change? Phase change means change of state. Change of state. So when I say phase change, it's the change of state from one state to another, from solid to liquid, from liquid to gas, from gas to solid, from gas to liquid, from liquid to solid. So we have solid, liquid, and the gas state. The three states: solid, liquid, and gas. The change from solid to liquid is called melting. The change of state, or the phase change from solid to liquid, is called melting or fusion. So the change solid to liquid is called fusion or melting. And the opposite from liquid to solid is called freezing or solidification. The change of liquid into a gas is called evaporation or vaporization. And the change from gas to liquid is called condensation. Also, solid can change into a gas. Solid can change into a gas directly without liquid state, and this is called sublimation. From gas to solid is called deposition. For example, ice is a solid and the liquid is water. The gas state is water, vapor, or steam. So solid, liquid, and the gas state. Changing of ice into water takes place at 0 degrees Celsius. Also, water can change into ice at 0 degrees Celsius. So it's called melting point. The melting point of water, the melting point of ice is 0, and also the freezing point of water is 0. So 0 here is the melting point. Water can change into steam or water vapor at 100 degrees Celsius, and this is called boiling point. So the boiling point of water 100 degrees Celsius, water change into steam, and the melting point or fusion point is 0. So here the three states of water. We mentioned before that if you have an amount of water and this amount of water is heated, and you have here thermometer. You have a thermometer. To measure the temperature. If you measure the temperature, you find that the temperature will increase gradually, 20, 25, 30 after fixed times. But now, if you have an amount of ice, its temperature equals -5 degrees Celsius, and you put it into a flame. So the temperature starts to increase, and you will measure the temperature using the thermometer. So after a certain time, the temperature will be -4, -3, -2, -1, 0. After 0, the temperature will be, after 1 minute, the temperature also will be 0 degrees Celsius. Why? The temperature will stay constant, though heat is absorbed by ice. After another minute, the temperature is also 0, till all the ice change into water. So the temperature of the mixture will be 0 until all the ice changes into water. After this, the temperature will increase again. So it will be 1, 2 degrees Celsius, 3, and so on. So the temperature remains constant at 0, the melting point. So this heat, which is absorbed by ice, just change the state, change the phase. So this amount of heat just change the state from ice into water without a change in temperature, but only it causes what? A change of state or a change in phase. So this amount of heat is called latent heat. So latent heat is the energy or the heat energy. The energy transferred during phase change. And this energy doesn't change the kinetic energy, but it changes the potential energy of the particles. Change the potential energy. This potential energy is due to the attractive force between the particles of a substance. Now, to change from solid into liquid, we should overcome the attractive force. So we increase the potential energy. So this energy doesn't change the kinetic energy, but only change the potential energy. Let's continue heating, and this heat to change from solid into liquid is called heat of fusion. Why? Because the changing from solid to liquid is called diffusion. The amount of heat or quantity of heat needed to change 1 kilogram of solid into a liquid is called heat of fusion. So heat of fusion means what? Energy added or removed per unit mass. Per unit mass. Here energy is added when the substance changes from solid into a liquid. So to change a substance from solid state to a liquid state, you should add energy. If you need to change from a liquid state to a solid state, energy is removed. So this is the heat of fusion. For example, latent heat of fusion is called LF. Latent heat of fusion of ice equals 3.33 times 10 power 5 joule per kilogram. The measuring unit of latent heat of fusion is joule per kilogram. It's the amount of heat added or removed per unit mass per kilogram. So what's meant by that? What's meant by the latent heat of fusion of ice equals 3.33 times 10 power 5 joule per kilogram. It means that if you have 1 kilogram of ice at 0 and you need to change it into water also at 0. So here ice at 0, 1 kilogram of ice, and you need to melt the ice, just melt, to become water at 0 without any change in temperature. You need what? 3.33 times 10 power 5 joule of heat to carry out this process. So this heat is just only change the state without a change in temperature. If you have 2 kilograms of ice, what's the amount of heat? If you have 2 kilograms, so the quantity of heat required equals 2 times 3.33 times 10 power 5 joule. If you have 3 kilograms, so Q equals 3.33 times 10 power 5 kilogram joule, and so on. So here we have Q equals mass times LF. Q equals the mass times latent heat of fusion. If you have 100 kilogram, 100 times the latent heat of fusion, and so on. Let's discuss an example. Find the quantity heat needed to change 0.5 kilogram of ice at 0 into water also at 0 degrees Celsius. Pause the video and solve. After finishing, you can play the video again. Here we have mass. So given mass equals 0.5 kilogram. And also latent heat of fusion of ice equals 3.33 times 10 power 5 joule per kilogram. Unknown here is, what's the unknown? The unknown is Q. Q equals MLF. The mass equals 0.5 and the latent heat of fusion of ice 3.33 times 10 power 5 joule per kilogram. So the answer will be 1.7 approximately times 10 power 5 joule. Clear, guys? Now we'll heat the water again. Water will be heated. The temperature of water will increase, will be 10 degrees Celsius. Will be 10, 20 degrees Celsius, 30, 40, and so on, till it reaches 100. At 100, the temperature remains constant, doesn't change, doesn't increase. It will be 100 also, till all the liquid water it changes into steam. After changing water into steam, the temperature starts to increase again. The heat which is absorbed here just changes the state from liquid into a gas. In this case, this is called heat of vaporization. Heat of vaporization. So, heat of vaporization, it is the quantity of heat or the energy added or removed, energy added or removed per unit mass to change from liquid into gas, and takes the symbol of LV, latent heat of vaporization or heat of vaporization. V here stands for vaporization. Similarly, Q in this case equals mLV. Quantity of heat required to change an amount of a substance from a liquid to a gas equals m, the mass, times LV. Clear? So, to change a substance from solid into a liquid, while here, for example, ice, if you heat it from -5 to 0, the temperature starts to increase. Here at 0, here at -5. At 0, the temperature is kept constant, no change in temperature. So here is ice. Here, ice plus water. Till ice changes completely into water, then the temperature increases again. Till the temperature reaches 100, the boiling point. The temperature is kept constant till the whole water changes into vapor and it starts to increase again. Okay? So here is only water, in this area is called water. Here water plus steam or vapor. Here is only steam. So this is called heating curve. So the heating curve is the curve that relates the amount of heat gained and the change in temperature. This is the heating curve for ice. Starting here for ice, for example, from -25, its temperature will increase and the temperature will remains constant at 0 till the ice changes completely into water. Then the temperature starts to increase till the water starts to change into steam. The temperature remains constant at 100 degrees Celsius. After changing water completely into steam, the temperature starts to change again. So the temperature doesn't change until a change of phase takes place. This is our lesson today. I hope that you understand this lesson. Until we meet again.